Hi folks, this is data taking for lab number 4, combining forces. Do forces act like vectors is the question. And vectors, you know, don't add just like numbers. You actually put the tail of one vector on the head of the other vector, or learn some really cool mathematical component method from chapter 3 in the book. So I'm going to actually take the data for you. The setup looks a little bit differently than what you probably would have had on your dining room table if you had your lab kit. These things are newtons of springsness, and you just arbitrarily pick one is A, one is B, one is C. A plus B should give you a resultant, and C should be equal and opposite to the resultant if you took good data. That's what we're hoping to find. I think I'm just going to send you 4 pictures, either on a Word document or a PDF. I'm going to send you 4 of these pictures. I've already just done this one, and so once you get the picture, I can take this thing like I showed you in the previous video and write down the forces, and that's all you will need. So I'm going to do this 4 times and give you 4 pieces of paper to do your lab from my data. Okay, I finished trial 1, 2, 3, and 4, but I left it blank. You're going to get a straight edge and just draw a really nice line down a line of sight, and use these lines as guides to make a parallel line. Get a line drawn with a meter stick that's parallel to these lines so that you get the actual line of foresight. Just draw a straight line down there, straight line down there, and then either on graph paper or on this paper itself, draw arrows to scale. In other words, 10 newtons, 10.0 newtons, that's supposed to read. Draw an arrow that represents 10 newtons. If that's 10 newtons, then 9.3 newtons is going to be almost as long, and 6 newtons is going to be a little more than half that size. So draw the lines to scale, put the tail of B on the head of A, or put the tail of A on the head of B, keeping the angle between A and B, so you need a protractor to measure this angle, and then do it graphically. I'm also asking you to do it component method from chapter 3, and that would be either breaking A or B up into 2 components. You want to make life easy? Put A right on the horizontal, then you don't have to break up A, you just have to break up B into 2 components. If you know the angle between them, you can figure the X and Y components of B, and then see if C is equal and opposite to the resultant of those. So there you go. Lab number 4. Data will be on its way.